right. All right. This is the end of exam 1. This is going to be the last video for this exam that I've recorded so far, at least. I don't know how this extra credit's gonna roll out. Hopefully I can get it all done by tonight. We're looking at T-minus 3.5 hours now. And it shouldn't be a problem. So let's get started. We're going to use squeeze theorem to prove the following limits. That is the limit as x approaches 0 of the cube root of x times cosine of 1 over x. Cool. So, starting out with the function, cosine, we know that cosine of 1 over x falls in between the range of -1, cosine of 1 over x falls between -1 and 1, because cosine is a wave. Now, we're approaching 0. So let's see where this takes us. When we apply the rest of the function to these bounds, so we have the lower extreme and the upper extreme of the function, and we're trying to find out how 0 will fall in between these two. So if we multiply, kind of just add in the next part of the function, -1 times the cube root of x is equal to cube root of x times cosine of 1 over x, 1 times cube root of x. We're just gonna add that in, and we are approaching the limit as x approaches 0. So we're gonna plug in our x value on both sides, and what we find out is the cube root of 0 is 0, and we know that anything multiplied by 0 is just 0. So we're going to multiply our upper and lower times 0, and we see that we've kind of sandwiched or squeezed our function, if you will, down to what it really comes to. And we see that by squeeze theorem, when we add in our function of sine and we sort of approach 0, our function will divide and divide, sort of diminishing it, squeezing it into 0 until it touches 0. So that is how we know that the limit of the cube root of x times cosine of 1 over x as x approaches 0 will reach 0.